get together on a brown bag on corridors. I think it'll certainly be the last CAD one of the year here. It's kind of a follow-up to the alignments and profiles one we did about a month ago. Obviously, you have to kind of, we'll talk about why that's important, but your corridors are pretty much entirely based on alignments and profiles as in terms of how they're set up. So start with a quick safety minute, just talk. I want to save as much time to actually get into CAD as we can. So just a couple quick topics in this actual PowerPoint here about just kind of what are some of the components of a corridor and kind of what the terms targets, regions, and frequency mean with respect to corridors. And then we'll jump into CAD. So just a quick one as we're approaching kind of Christmas time and New Year's. Theft does go up this time of year. My wife and I both had our cars broken into last week, and as well as several others, I guess, within about a 1.5 mile radius of our house, according to the Ring app. So just, keep in mind that, make sure your cars are always locked. Keep valuables outside of your cars. If you are gone or away, try and leave some lights on, or at least on timers. If you're having packages delivered, make sure that you're tracking those as to when they're going to show up, and see if you can contact someone trusted if you're not able to pick that up right away off your front porch or whatever that may be. Follow up to Anna's presentation on Monday. Just be careful when you're cooking, and pay attention to stuff that's on the stove or in the oven, or if you are doing something outside with a deep fryer. I know some people like to do those. Keep any decorations and candles and lights in good working order, and always monitor any candles that are lit. Those are a pretty high cause of fires this time of year. Not much going on for most people with regards to travel this year, at least. But if you are leaving for a long weekend or something, try not to post too much about it until you're back, so that people don't know that you're going to be gone. And if you are going to be traveling, try and let someone know that, just to try and keep an eye on your place while you're gone. All right. So kind of some basics of corridors and how you kind of get started. I just mentioned that you kind of need to have your alignments and profiles set before you can kind of get into building your corridor model. So make sure that those are established and at least, roughly designed. The benefit of corridors is that they're pretty easy to update if you do have a change in your profile design. So at least have your alignment set. You're going to need that to build your corridor. And then you need to have at least a profile roughly cut, at least. Determine what your road sections are going to be. And there's likely going to be more than one. So you want to think about what those are going to look like. And in general, you want to try and keep as few of sections as you can, but obviously, we have to design to what the kind of roadway is requiring with regards to ADA ramps and driveways, or if you've got stormwater planters for a portion of it. So you kind of need to just kind of think about what all your road sections are going to need to be, so that you can start, building your assemblies down the road. And again, kind of think of what those variations are from the standard section. If the majority of your road is if it's a new road and you're doing 20-foot wide half widths with curb and gutter and planter and sidewalk on each side with a daylight, then that's pretty straightforward. That's kind of your baseline section. What are the deviations from that? Where do you have swales? Where do you have curb tight sidewalk on one side? What are those different sections from that kind of baseline section? So what are the required subassembly parts? And we'll talk about what a subassembly part is, but effectively those are, your lane pieces, your curbs, sidewalks, could be daylights, could be retaining walls, could be, generic links for a stormwater planter, something like that. So we'll talk a little bit more about what those are here in just a second. So a baseline. So the baseline is effectively the starting point of your corridor. The corridor is going to build outward from your baseline. And a corridor can have multiple baselines. Generally, those are established as your roadway centerline alignment. But your corridor can also have a baseline that could be, your flow line, a curb return profile, maybe a saw cut line. It's essentially anywhere where you're starting an alignment to basically work outward from to build your roadway section. So the assembly is kind of the complete, if you look at the image in the bottom right here, the assembly would be the entire compilation of all of those elements. So it'd be a lane, it'd be a daylight, it'd be, a ditch section or a catch section in the example of this image here. You really want to make sure that those are named well, because when you get into assigning those to your corridor, it's going to be really important that you have those named well so you can pick the appropriate section for that specific length of the road. And I'll try and show some examples of what that looks like when you're actually building the corridor. So on a new road, you're pretty much always going to have a left and a right section. But if we're doing a half street, you may only have a right or a left, meaning just the right side of center line or just the left side of center line. So it's important also when you're building your assembly that you're identifying which direction the alignment is heading, and what that means when you're building this assembly. So when you're building these, you're always looking up stationing, meaning if you're looking at the right side of center line, you'd be looking up stationing, and everything on the right side of the baseline would be right, and everything left would be left. Pretty common sense, I think, but you just got to make sure you're looking at the stationing the right way. And then the sub-assemblies are the individual pieces of the model, of your overall assembly. So, this lane piece would be a sub-assembly component. This conditional cut or fill sub-assembly would be a single sub-assembly component. So that's generally your lanes, curb and gutter, planters, sidewalks. Sometimes these are the same. They can be the same sub-assembly. Daylights, conditional sub-assemblies. I'll try and talk a little bit about what those mean. Walls, pretty much anything that's a single component of your corridor model. These are also very important to label left and right, and I'll explain why that's the case when we get into the model. These, when you put these in, they'll have a generic name that says, lane super elevation, AOR is what it's called, but it's really important that you label those correctly, because you may have the same sub-assembly piece more than once per assembly. So you may have a link here and a link here that may have the same generic name, but once you get into the corridor properties, it's hard to tell which one's which. So it's important that you change those names. Let's see. So targets, regions, and frequency. So targets, there's certain sub-assembly pieces like the lane or sidewalks that you can set a target, generally either a feature line, polyline, or an alignment that you can use to target either vertically or horizontally. So you may have a piece of roadway or a lane assembly that has a default width of 10 feet because that's the majority of your road is 10 foot in width, but there's a section of it that jogs out to 12 feet or 15 feet. So instead of building an entirely new assembly, you can basically just draw a polyline on that edge of pavement and set a target, and the lane will adjust to that width. So I'll show you what that looks like when we get into the CAD model. So regions are the kind of specific kind of alternate sections. So, you know, if you have your baseline region is pavement, curb and gutter, and sidewalks. If you have a section of roadway where the sidewalk goes away for whatever reason or switches to curb tight, you would put a region break in your corridor. So that would be from a specific station, station range from station 100 to 200. The corridor section is this, from 200 to 300 it's this. Those are separate regions. And then frequency. Frequency is the amount of sample lines that are cut across your baseline. So the way the corridor builds is it builds outward from your baseline, and it effectively builds a cross section starting at whatever your profile elevation is on your baseline. It will calculate the points of each end of lane, flow line, top of curb, top back of curb, face of sidewalk, back of walk, right of way line, daylight. And the frequency says how often along your alignment, your center line, do you want it to calculate one of those sections. And the frequency can be set to increase if there's a horizontal curve or a vertical curve in your center line alignment or profile. So it's important to know kind of, if you're on a pretty big radius, you might not need as tight of a frequency. If you're on a really narrow radius, like a curb return, or you just need more detail in your surface, you might want to increase your frequency where you've got vertical curves or horizontal curves. And I'll show you how to do that when we get into the CAD. So that's kind of all the background stuff. I was going to jump into CAD. Does anyone have any questions on that before I get into CAD?
Makes sense to me, Mike.
Excellent. Well, I guess with that then, I will open up CAD. Can you guys see the CAD, or is it still the PDF or the PowerPoint?
We can see your CAD.
Excellent. All right. So this is a project. This is a project that we did down in Salem back in 2014. It was a Goodwill project that had the Goodwill building, 2 pad buildings. We vacated a street down the middle. We had frontage improvements on ODOT, frontage improvements on a city street, a new city street here, and a new extension of a city street here. So pretty extensive offsite improvements. Certainly not one you would try and do with feature lines. I know that sometimes when we're just doing simple frontage improvements, it can be easy to want to just say, well, it's quicker and easier for me to just throw a couple feature lines on it and offset them back and call it good. But I really want to encourage people to think about what that is going to mean when potential revisions are needed, or when you get into, needing to create your sheets for the submittal to the city in terms of, or whoever the jurisdiction is, in terms of what data are they going to require on the plan sheet, and how are they going to need to see it displayed. meaning most frontage improvement plans are going to require a profile. And if you're just doing your design with feature lines, it's much harder to get that to profile properly and accurately to match the actual grading of your surface if you do it with feature lines. The other piece of that is, if you remember during the profile brown bag, generally if you have grade breaks that are over 1%, you need to have a vertical curve. You cannot do a vertical curve with a feature line. So, again, labeling those and calling those out for the contractor and for the jurisdiction to review is pretty much impossible with a feature line. So that's not to say that there isn't ever a time where we might not just do a frontage improvement with a simple feature line. But really early on, think about what you're going to need to display. And if you're going to need a profile that is proposed, not just cutting an existing profile of the center line or something, and we're not really doing any work out there, then I would strongly recommend that you consider if a corridor makes sense. So to keep things simple, since we're just kind of talking about the corridor basics here, a new roadway is 100 times easier, in my opinion, than a half street. A corridor for a half street is, if you have curb and gutter, a corridor for a half street can be very complicated. And I'm working with Autodesk to come up with some solutions for that, but we've yet to come up with one that's better than what we've got. And I can touch on what that is when we get to the end here, but I want to make sure that we kind of cover at least the basics of, how do you set up a corridor? How do you build an assembly? Things like that. So, I kind of said the first step is, establishing your alignment. So to save time, I just pulled the old file. We've got our alignments of all of our roadways here already set up. Over here, you can see we've already got all of our profiles built as well. So we'll kind of skip that step. So the next piece is, establishing, what is your dominant kind of roadway section? And we'll start with this one. So this one was effectively a 12-foot lane on each side with a shoulder, a 5-foot shoulder, and then a catch to daylight. So, and then we'll look at the second one. We'll ignore the swales because those add some complication, but it's all fairly straightforward once you kind of understand how the corridors are built, are set up, and how they build the model. So for now, we'll just assume that it's the roadway, curb and gutter, a planter strip, and a sidewalk. And in this case, because we're tying into our proposed finished grade surface, we don't really need a daylight on that section. So let's focus on, we'll build those two sections real quick. And just as a tip that I always used was, or always use if I'm working in corridors, is always have a split view. And I don't think you guys will be able to see it, but I tend to, with two monitors, I tend to basically minimize my CAD and then have the split of the two views centered on the monitors so I can have a full monitor view of each side. But, again, that's all just kind of personal preference. So let's go back over here. And I'm sure you all know that, profiles and, assemblies and stuff, this was the group of assemblies that we used to build the corridor model for this project. We'll kind of ignore those for now, but those all show up as, true vertical. So this helps to have your, a D view set for one side or the other. So for now, we will ignore those. And we'll start with building our first assembly, which if you remember was basically just a 12-foot lane and a 5-foot shoulder with a catch line. So we can start with, you go up to the corridor menu, click on Create Assembly. And here's where you get your chance to kind of name your assembly. So you always want to start with what's your baseline. Or if all your roads are the same, you may not need to do that. But if your road widths are different or your road cross sections are different, meaning, you know, one may have curb and gutter, one has standard curb, or one has curb tight sidewalk, the other doesn't. You generally want to name them by street. In our case, all of our sections were pretty different. So, you know, Second Street, no curbs. If you have different shoulder conditions or things like that, you really just want to be as descriptive as you can, so you know which section you're, you know what your section looks like just by knowing the name. So if we're good with that, I'd recommend changing this this code set style. At least in this drawing, I need to confirm in our new CAD template if having this on sections works. But I know in this drawing it's better, it displays better if it's on basic. So I'm going to just change that, but I would need to get back to you if you need to do that on our current dowel template. So once you click that, it'll basically ask you for, you know, where do you want this to be placed? It doesn't really matter. Generally, I place them off to the side of the profiles and try and keep them kind of organized by street. So you'll see all of these ones are Second Street. All of these ones down here are Melinda. And then I think I had some curb return ones up here. Yeah, so CR I use for curb return. So back to our assembly here. So I think everyone should have a tool palette on the side that they can open up or add to their to a flyout window that's for civil Imperial sub-assemblies. And I'll flip through some of these, you know, fairly quick. We've got some that are pre-built. I've never really used these. I suppose they work just fine, but it doesn't take a whole lot of time to just build one. So your lane section, the one you're going to use the most is lane super elevation AOR. That allows you to, if you're building a detailed corridor, you can add super elevation to it. That gets a whole heck of a lot more complicated. So if you are getting into a super elevated road section, I may be able to help. I've only done it a few times myself even. So that's generally the one you're using there. Shoulders I don't really use. I don't really use medians much either. You know, we're generally not getting into detailed enough corridors to do that. Curbs, I generally use urban curb and gutter general. For some reason, sidewalks is in curbs as well. So urban sidewalk is what we use. And then this is a custom one that we have that I can send everyone, and you can load it into your tool palette. This allows you to set a variable height curb across a section, which is useful when you're dealing with ADA ramps or driveways. You can set it such that you've got basically from one region, the start of the region to the end of the region, the curb will transition from a start height to an end height. And that can be helpful so you don't have to, you know, build your entire driveway drop or something with feature lines, or, you know, leave the curb out of your model for that section and hope that it tins properly. You can use that variable curb and we'll calculate that across the length of the region. Let's see, daylights, there's a whole bunch of different daylights. We'll talk through what some of those do. Generic, we use these pretty frequently when we're talking about, maybe a roadside swale, or this is what I tend to use for shoulders as well. Sometimes on a half street, you may use this to get between your center line. If the jurisdiction requires that you profile center line, it's generally easier to build your corridor from the center line out, so that all your profiles can be labeled off the center line. But if you're not starting your model until the saw cut line, you can use a generic link to get from the center line to the saw cut with a target, and then you can actually set these so that the corridor won't build that portion of the assembly. I can show you what that looks like. Let's see. Conditional sub-assemblies, we'll talk a little bit about those because those can be helpful. They can reduce the amount of thought it takes on your part to figure out if you're in a cut or a fill scenario, and what to do with the daylight section. So we'll talk a little bit about that as well. Those are the main ones that I use. There are some in here for walls that I've used before. I've never used any of the bridge stuff. The rehab, so you can use corridors to also calculate quantities as well. It's not something we generally do. That's more of a public road job requirement. But that option is there if you ever needed it. But you have to be very, very precise with how all of your stuff is entered into each assembly and sub-assembly to get accurate quantities. So that's kind of just an overview of this tool palette. And you can customize this, add things to it. I think you can actually add a custom one that only includes, if you only wanted to include, a couple of the lane ones, a couple of curbs, a sidewalk, a couple different daylight options, you can include them all on one tool palette, as opposed to having to go tab to tab. But so if we're going to start and build that basically lane section with the shoulders, we'd start with clicking on lane super elevation AOR, and you'll see that the command prompt says select marker point within the assembly. So marker points are shown in the assembly with these circles and occasionally with an X through them. Before you do that, you can go to your properties menu, and you'll see that even though it says no selection up here, it has a bunch of advanced or parameters down at the bottom that are associated with that assembly that you're in process, or sub-assembly that you're in process of putting into your assembly. So you can change the default side, right or left, meaning which side of the baseline it would come in on. You can change your default width. In our case, the roadway is already 12 feet, so we're going to leave it at that. Your default road slope. So if your jurisdiction requires 2.5%, you can change that. These are where you start getting into calculating quantities, so you don't really need to change any of those. Super elevation, if you're using it, don't really need to change any of the rest for the most part. If you're just building a basic road section, you don't really need to change the rest. So assuming we've got all that correct, we're going to build the right side of the assembly first. Click on the marker, and it'll ask you to name it. So this is where it's important to label which side it's on, right or left. If you're going to be, for whatever reason, using multiple lane pieces on the right side of the assembly, you would want to change this portion of the name to something more descriptive. For example, if you had maybe a curb bulb out where for on-street parking, where you have maybe like a valley gutter between them, and you used a lane piece for the travel lane and a lane piece for the parking, you would want to label those such that you knew which one was which. And I'll try and show you why that's important in a minute here. So once you've named it what you want, you can hit OK. It'll draw in that lane. And then you could keep going. You could add another lane, or you could add the lane to this side. Knowing that, we're going to have a lane on this side, you could choose now. I'm going to wait. Then with a shoulder, what I would generally use is a generic link for width and slope. And what that is so we can change this to right shoulder. That's a generic line, basically, that's built for a specific width at a specific slope. So if you go to the properties of it, you can see this is 10 feet. If you only wanted a 5-foot shoulder, you could change it to 5. Negative slope would be down. You can see it's asking you what the slope direction is. And if it's away from crown, positive is up, negative is down. So just keep that in mind when you're building this. And then if you wanted just a generic daylight section to catch to existing, you can use a few of these. You could basically say daylight to a surface at a specific width, which would be daylight to offset. Daylight max width will daylight at a specific slope unless it gets over a certain width. And that's generally the one I use. And if you go to the properties of that, you can change your cut slope or your fill slope. Those can be different. So the corridor will calculate if you're in a cut or a fill, and will change your basically your catch. If you say you don't care how far it goes to catch, you might want to just change that to 1,000 or 100 or whatever, something that certainly gets you beyond what you're looking for. That's generally the only things you really need to change there. And then it'll look something like that. It'll draw your line out to the maximum width that you typed in. So that is basically the right side of your assembly now. If your left side matches, you can select the whole thing, right click and hit mirror, and then mirror it across your center line. Same side, no, sorry, here. It asked me if I wanted to mirror to the same side because I accidentally clicked the marker for the lane piece, the circle on the lane. But if you click the yellow X, that's the baseline. So then what it'll do, it'll ask you to rename all those pieces. So it'll start from the baseline and work its way out. So now I'm on the left side, so I want to change that to left. I want to change this to left shoulder and left daylight. Okay, so that built your section there. If you needed to change the name of this for any reason, you can go to properties and change it up here. One thing that I also like to do is add a piece of M text below it. And instead of just typing in the name of it, you can add a field for an object. And if you click this button up here, I don't know why the snap shows up, but you can just click on the baseline and it'll ask you, it'll say the assembly, and you can click on name and it'll add the name of your assembly just below it, and it'll be linked to that. So if you change the name of this, it will update your M text after you regen. which is handy if you're, looking at your assemblies and needing to, quickly determine what you named something. So the other thing that you can do is, so if you have an assembly that's very similar to this, so in our case, the next section that we have is with a sidewalk, but the left side stays the same, meaning it's just a shoulder with a daylight. So you can take this, and if you just select the baseline and the piece of text and copy that, it will copy the whole assembly. And if you regen, not rotate, regen, what just happened? It will, why did it name it the same? What do we got? Somehow those are the same name. But anyway, if you change that again, or 2nd Street sidewalk right, in theory, that piece of text should still be linked to the one that you copied. So you don't need to redo the field every time. As long as you copy the text with the baseline, it'll keep it. So now we want to add a curb and sidewalk to the right side. So we can just select the daylight and the link and just hit delete. Go up to your tool palette again, add a curb here. Right curb and gutter, that's fine. And then urban sidewalk, and attach that there. And if you look at your sidewalk piece and go to the properties, there's an inside boulevard, a sidewalk width, and an outside boulevard. So what those will do is those will basically add a planter strip. So if you have an 8-foot planter, you can type in 8 feet. And in our case, our planter was 8 feet. Perfect. And then outside is, if you have a 1-foot separation to right of way, you can add in a 1 foot, and that will only go at whatever the slope of your sidewalk is. However, so if you have a variable width planter, or excuse me, variable sloped planter, you won't be able to use this for that. You would want to use a link, and you'd have to set a vertical target, and I can try and explain that later. We won't be able to actually probably build that, but we can talk about it. Okay, so and then again, since we were tying into our proposed surface on site, we don't need a daylight over here. So we'll go back to, let's just go back to one view for now. So if we want to start building a new corridor, now that we've got our assemblies built, you can come up here to corridor and create corridor. So you're only going to build, even if you have multiple roadways, you're likely only going to build one corridor model. If they're completely separated, you could build two. That would be fine. But if you've got like an intersecting street, for example, this street and 2nd Street would be the same corridor model. So when you're creating a corridor, you don't necessarily want to name it just 2nd Street or Melinda. You'd want to say, offsite corridor or public street corridor, something descriptive that doesn't necessarily make it seem like it's only one of the streets. Corridor style basic is generally what we want. It'll always set up one baseline first, meaning, it's going to start building whichever alignment you pick first. So in our case, we're going to build off 2nd Street first. So it's asking what the baseline type is. Generally, we're going to build this off an alignment and profile, but technically, I guess you can build them off a feature line. Again, I wouldn't necessarily recommend that for a roadway. You should always be doing alignment profile. So if you're doing alignment profile, we'd want to select 2nd Street right-of-way center line, and your profile, assuming it's a new street, would be your FG, your finished grade center line profile. Then it'll ask you for what assembly you want to set up for the initial, basically initial build out of your corridor. You can leave this as none, and it won't really build anything at first. You can always change it, add regions and change that later. But if you want to, if 90% of your corridor is going to use the same section, it might be helpful to select a your most common section and have it build it all the way through, and then split and change regions as you go. If you have a lot of different regions, it may make sense to just select none and start building out your corridor just one segment at a time. So in our case, I'm just going to select no curbs and say that's our dominant kind of corridor section. And then if you do have a daylight surface or a daylight associated with that, it'll ask you what your target surface is. And that's what surface you want those daylights to search for when they're building the model. So we would set EG and we'd hit OK. And this would show up. So when you're looking at this screen, this will be your baseline. It'll ask you, this top line here will be your baseline. It'll ask you what your horizontal baseline is and your vertical baseline, which is your alignment and your profile. You'll have a start station and an end station. You'll have a frequency tab, which if you click on the baseline, you can set the frequencies for the entire corridor baseline, regardless of what the regions are. Or if you have multiple regions, meaning you've got, your sidewalk section is a separate region here, you can set those individually by region. Targets, again, we'll touch on that in a second, but that's if you had, variable width pavement or something that you wanted to be tracking a different width. And then overrides, you generally don't need to use a ton of, so we won't touch that today. In this piece, if you decide that you clicked your no curb section and you wanted to change, the end station, you could change that here if you didn't want to run it the whole length of your corridor. But for now, we'll just hit OK. And there you go. It builds your corridor for you. You can see it calculates your catch line to existing. That's the outside line here. If it's green, at least in this style, green would mean you're in a fill, red would mean you're in a cut. So it differentiates between the cut and fills on your daylights. Where they come together, that's basically your transition point. So you can see, it basically built it out. The edge of roadway is right underneath the edge of the corridor. So each of these lines that's now drawn here represents basically a feature line that is built by the corridor on those endpoints of your assembly. So that is, the outside edge of your lane. So every one of these circles effectively gets a feature line built at that location. And then again at the end here. So you could, if you wanted to, you could extract those feature lines and use that as part of a tie-in. That might be what you'd want to do here. If you were tying your on-site surface into the off-site, you'd extract that feature line and use that, add that to your FG surface on site to make that tie-in. With that said, we now know that, we don't want to take this section through the intersection, because once we're on the other side of the intersection, we have a sidewalk. So if you want to basically switch a section to your sidewalk, you can click on this, click on the corridor. And if you go, you can see that it brings up basically a corridor ribbon. And this is really helpful for editing and adjusting kind of everything there is about your corridor from a design standpoint. So this modify region tab basically lets you either, split a region, meaning if I split a region here at the endpoint of the curb return on this side, I guess first it asks you which region you want to split, and then it'll ask you for, the station. So these two sections are now different regions in the corridor. Granted, they're still using the same assembly. So if you wanted to change that, you could click on region properties, select the region, and you can change the assembly to sidewalk right. That's what I wanted. And you can see that it'll change that to be your new section. So across an intersection, I don't necessarily want to build sidewalk across an intersection here. So I'm going to split that region again, select it. And if you accidentally click the wrong spot, you can always just change this grip or grab that grip and click on wherever you want to move it to, and it'll slide it to that point. Alternatively, you can right click and go to corridor properties and go to parameters. And you can see when we started, there was only one region under the baseline. There's now 3. And you can see that it basically just changed the name and said, no curbs copy, no curbs copy 2. You can edit those names to whatever you want. And it can be helpful to basically name those so that they match your assembly section or your sub-assembly section. Excuse me, no, your assembly section. Now that you've got that kind of split, so again, we don't want to build sidewalk across here, so I'm going to modify the region. You can, again, you can right click on all this stuff, or most of it shows up in the ribbon. So if you wanted to modify that one, we could say 2nd Street, no right. And we didn't build that one. That's one that I think we had in there. I'm assuming that's what that was. Sure, that'll work. Okay, so we've got kind of the main section of the corridor built. You can see it's calculating effectively to the back of walk, except where we got to this point, we had a wider road section. So we went to a 15-foot lane instead of a 12-foot lane. So if you recognize that, you can just come over to your assembly and change the width of your road. And you can see it didn't do anything in the corridor yet. So you can click on it and hit rebuild corridor, and it'll update it automatically. And it'll recalculate all of those grades across your section to that point. The other piece of that is you can see that we've got, we've got a curb and gutter section in our assembly. So if you're not modeling that gutter, or if your road doesn't have a curb and gutter, then you need to change that gutter piece. And the curb is one of the more complicated ones to edit, because all it says is dimension A, B, C, D, E, F, G, and you can change all of those dimensions. Keep in mind, those are all in inches. So to understand what those are, you can go to the tool palette, right click on it and hit help. And there's this kind of handy diagram that shows what all of those dimensions are. So the most common ones that we update are B, D, F, and E. So F is the top width of your curb, from the top face to the back of curb. E is the bottom width, meaning that it generates, when a corridor models a curb, it models it as a 3-line curb, meaning it's going to build 3 feature lines. When we model on-site curbs, we're generally drawing them as 2-line curbs, meaning bottom face and top back. A corridor is going to model all 3 because a corridor cannot, I suppose you could do it with a 2-line and just skip this and you'd have to use a generic link, but a corridor cannot have a true vertical. You can't have 2 XY coordinates with the same elevation to it. So it's going to have a batter on the face of curb. So you're going to want to set F. If you truly want to draw it as a 6-inch curb, you're going to want to try and draw F as 5 inches, E as 6 inches, and that'll make this line here, your flow line and your top back, 6 inches apart. And then B is your gutter width. And you'll see that if you type in 0, meaning no gutter pan, it freaks out because it's trying to put 2 points on the same location. So you want to put 0.001, and it'll basically fake in a point that is, 1/1000th of an inch off. So it never impacts the model. If you are modeling your gutter, you can change a couple different things. You can change your gutter slope, and you can change if it's a shed section, you can change, the slope of that going either negative or positive, and you can change the width of it again, using that B dimension. So hopefully that all makes sense. Again, so we just made a bunch of changes there. Let's assume that we are not modeling a gutter pan. We don't have to change it again. And then you can see everything now lined up. The curb is on top of the curb, sidewalk's on the sidewalk, and we've got basically the sidewalk width and then a 1-foot extension at 1.5%. So with that said, let's say that we realize, well, shoot, we needed to transition this part of the roadway here to a 15-foot width also. So that's what this is. So our road width changed, at this point, once we came around this angle, this little curve in the road, it's going to slowly transition to 15 feet from 12. So you can go into, again, select your corridor. Under modify region, you can click edit targets, select your region, and here's where the naming becomes really important if you have multiple assemblies or sub-assemblies within the same assembly. So it's gonna break it up into a couple different things. Surfaces, which is effectively your daylights, or any links that are linking to a surface. It's going to break it up into width targets and then slope or elevation targets. So you can see that some of these are named, right lane super elevation. That was our pavement section. That shows up in both width and slope or elevation. That means that you could, if you wanted to, you could target a feature line or a profile with this right lane alignment or subassembly piece, and it would change the elevation regardless of what the default slope that you put on that subassembly. If you say we put 2.5%, if you have a feature line or a profile, you can target that profile for just a portion of your roadway, and it will change the grades and calculate the cross slope from the center line to whatever that profile elevation is. Does that make sense? Hopefully.
Yes.
If it doesn't, feel free to raise your hand and I'll try and explain that differently. So a width target functions similarly in that, it will target a line horizontally and adjust it, adjust the width of the lane piece. So if you only pick a width target, it will continue at that width until it hits that line at whatever your default slope on your subassembly part was. So in our case, we don't want to change the elevation. We just want to change the width. So it gives you two options, either alignments or feature lines or polylines. I generally do all my targets unless I've got a curb profile or something already drawn. I'll just generally just draw polylines. Because generally you're just basically taking a nested copy of a curb line or something like that, and that's your target. So you can hit select from drawing, and then you can click on your line. I will generally put all of these on a Z-corridor targets line, just so that they're clear as to what they are. And you can see that what it does is it basically adds that as it's target number 1, it's a polyline, and then it adds a generic name to your polyline. You can have more than one target, more than one polyline target per region for the same subassembly piece. So, and what it does is it'll go to whichever one it finds first, building out from center line. So if that's the case, we wanted to do that. You can see if you named all of these without a right or left, it would be pretty much impossible to identify if you were on the left or right lane, or if you had more than one lane, it would name them both right lane super elevation AOR or AOR-1 or -2 or -3, however many you had. And if you didn't label them, you would never know which piece to target, which target you need to set. So that's why the naming piece is really important especially if you're using more than one of the same piece per assembly. Okay, so you saw that updated when I hit OK there. It basically took the width of the roadway now out to that target line, and then it adjusted the shoulder, adjusted the catch line with it. So one thing that's helpful with this here is, before you even got any farther, you saw that our catch line is now outside of the right-of-way line. That's helpful to know that basically that means I need a wall, or if this was our right-of-way line, it's not, but that would show that we'd need a wall or a steeper slope or a narrower shoulder, or we need to potentially offset the center line, or do something to the roadway section to avoid grading on someone else's property. Okay. Anyone have any questions on? Well, I guess let's do this real quick. Let's look at frequency. I'll show you what that means. So this was our centerline profile for 2nd Street, and you can see we've got a vertical curve, a couple different vertical curves. From 102 to 102.5, and another one from effectively 103 to 104. So if we look at those are somewhere right in here. If we wanted to have a more frequent sample point along there so that it calculates the vertical curve a little bit smoother, make your contour show up a little cleaner, you can again click on your corridor under the Modify Region tab, which is, you can probably guess, is the one you use the most. You can click on Edit Frequency. And then again, it'll ask you which region you want to pick. We want to pick this one. If you only wanted to modify it for this one, if you wanted to change it corridor wide, you could go into the properties and change it for the whole thing. But you can see here, this window pops up and it says, you can increase the frequency along a tangent. I generally leave that around 10. If you've got a really straightforward road section that doesn't have a lot of grade breaks or horizontal change to it, or really any difference in the profile. You've got a 1,000-foot long road that's at 1%. You could probably increase this to 25, but most of the time we're doing small enough frontages that 10 probably makes sense. Along a curve, you could change a horizontal curve. You could change that to 2. If you have a spiral curve, you're in a more complicated road design anyways, so you can change that, but generally we're not doing spiral curves. And then along vertical curves, I generally go to 2. Sometimes you want to go to 1, but it's generally not necessary. You want to make sure that if you do have a target, that you always have one at the geometry points of that target. So you'd want to have this at yes. And then make sure that you've got these boxes checked yes for high points, low points, any vertical geometry changes, horizontal geometry changes, things like that. So if you hit OK, you can see that effectively this whole thing is one giant curve. So it added a lot more sample points along the feature line, or along the corridor length. And you can see over here it didn't add anything. So if I were to change that back to 10 for a horizontal curve, you can see now it's only adding them at the vertical curve locations. So that's the frequency. If you needed for whatever reason to add a single frequency point or delete a frequency point, you can do that here. Actually, I don't think you can delete a sample line. You can delete ones that you've added, but you can't delete one that's calculated by the model. But if you wanted to, for whatever reason, there's a specific point that you wanted to have a sample line through, you can add one here and just select a station. Okay, I think that's the basics of building a corridor. But you'll notice that there's no surface here yet. So to do that, you can click on it and click Corridor Surfaces. And it'll bring up this window here. And there's a couple things that you want to do here. So we're generally always building a top surface. But in theory, you could build a surface that's your subgrade, or a surface that's at the first lift of pavement, or whatever that is. Again, that's for building quantities or public road job type corridors. We're generally always going to want to build top. And then you can either do data or links or feature lines. I'm pretty sure you want to build it as links. And then you can click create a surface here. They'll name it FG offsite corridor. You can change your surface style, whatever you want that to be. These don't really matter. And then you'll see that there's not really much you can do here. You have to click this plus to add the data to it. So it built the surface, but it wasn't going to have any data associated with it until you click that plus button. And then I generally always click add as a break line. And what that's going to do is add a break line at all of those marker points in your subassemblies. So if you hit OK, rebuild the corridor, now it'll add your surface. Let me see if I can turn that up. Actually, surface edit. So if you're looking at it from a tin standpoint, you can see, it's basically going to go from, it's going to add a tin line across your baseline, across the edge of your lane line, your outside shoulder, and then out to your catch line, and then triangles between them. You can see this makes, in vertical curves, it makes your contours, pretty smooth. They're rounded. You don't really need to add a smooth surface to a corridor. I would highly recommend you don't add surface smoothing to a corridor. In theory, if you built it right and things like that, you really shouldn't have any of those issues where you're tinning across center line or something, unless you're starting to mess with actually flipping faces, which very, very rare circumstances do you really need to change the way that a contour or a triangle is tinning in a corridor if the corridor is built correctly. What you do need to sometimes do is you'll see that where we had our transition from a cut section to a fill section, it's tinning across those boundaries. So you can do a couple things. You can draw a boundary around your corridor, which is what I tend to do. I think it's easier and it works a little better, but you can get lucky sometimes, and you can add a boundary that says add the corridor extents as the outer boundary. And that sometimes works. Let's see if it does here. So it worked in that case. Where it tends not to work is occasionally if you start adding multiple sections to it, or having to add feature lines to the outside of it, or to within your corridor limits. So you can, if you really want to think about how the corridor is going to build, you can build ADA ramps in your corridor. It takes a little time. It takes a lot of thought in terms of how the section is built, the assembly is built, but in theory, you can do it. I generally don't do it that way, but what I do use is I build the curbs and then build the ramps with feature lines behind it. So I try and get through top back of curb using the corridor, because those will always then be controlled by your profiles. So when you're designing a road, the easiest way to update your grading, or the thing that changes most frequently when you're changing grades or something like that, is your profiles. So your design of roadway is always built off profiles. And if you've got your curbs built in your corridor based on those profiles, then your back of curb is always going to be accurate. Let's see. What should I guess, does anyone have any questions on anything we've gone through so far? Those are kind of the high level basics of it. Does anyone have any questions on seeing an example of something? I was going to try and touch on, what you do at a curb return or an intersection next. But does anyone have any questions on what we've done so far?
I think I understand it to an extent. I'd have to actually do it to make sure I know it, but I think I got the concepts.
Yeah, I mean, the main thing with it is really understanding. You really have to understand how to build these. If you understand what assemblies you need, it's super easy to maintain a corridor. Once you have it built, and you make an adjustment to the profile, it recalculates all the grades automatically. I could go over here to this profile and take this point and move it up to here, and it would rebuild the entire corridor automatically. So the benefits of that are, obviously, I now don't have to update however many feature lines it took me to build this road cross section. And I never would have been able to build a vertical curve in the profile to begin with. But those are the benefits of a corridor versus feature lines when it comes to a roadway. And just as a heads up, if you are doing a lot of modeling or updates to your corridor, I would always recommend not having rebuild automatic turned on because it'll drive you crazy because every little thing you do will update and it'll rebuild the whole corridor. This one's pretty simple, so it rebuilds pretty quick. But if you've got a really complicated one with a lot of different regions, a lot of different target or frequency changes or vertical curves, a lot of different baselines, it can take a decent amount of time to rebuild every time. It can take 10 seconds to rebuild. And if you're making a simple change to one little thing, to have to wait for that to rebuild every time is pretty frustrating. So anyone else have any questions on that? I want to touch on intersections, then I want to give at least a rough idea of how we do half streets. And then I can show you kind of what the overall corridor for this whole project looked like when we were done. But anyone else have anything they want to go over on this piece? Okay. Okay, so intersections. So I'm gonna just I'm gonna turn the surface off again here real quick, and then I'm gonna add just a real quick. I'm gonna add a quick baseline to Melinda. So if you add a baseline and you want to start adding regions to it, you can go into your corridor properties, right click on your your baselines are the furthest out in the tree here. You right click on that, add a region, and then 3/4 no ditch. Sure, doesn't really matter. Yeah, that doesn't. It's not what I wanted, but that's fine. Again, you can always just change the extents of your region by just dragging it over. Okay, so at an intersection, you need to at least somewhat understand how the roadways are going to tie together. Meaning, if they're both crowned roadway sections, generally the higher classification roadway will maintain its crown, and the other roadway will transition to tie into it. So if this one is crowned and this one is crowned, this one may have to, transition its crown to line up with the roadway cross or longitudinal slope of the intersecting road. Hopefully that somewhat makes sense. In some cases, if they're the same classification, you just kind of merge the crowns together. So if you're transitioning to match a crown, you may have this corridor or this baseline merge into basically the flow line extended of the main roadway. If you're merging the crowns, you'll have the curb return blend the two to target out to the center line and center line of each roadway. I'll try and explain what that means here. So the way you do curb returns is you have a curb return alignment and profile, and that is going to become a baseline in your corridor. So if we select that, this would be Second and Melinda southeast curb return. Second Street and Melinda. So again, we added baseline, but it doesn't show up. So corridor properties, add a region, and curb return. We'll just pick the basic one here. We'll just say it's full height curb around the whole thing. Okay. So the way that curb return section was built, you can see this is where it's important to know the direction of your alignment around your curb return. But full height curb, so all it is, like I said, I build curb returns basically to the back of curb, especially if I've got ramps. If I don't have ramps, then you might build to the back of sidewalk, but generally you're not going to have a curb return anymore that doesn't have a ramp. So curb return is, the baseline is your flow line, and then your curb is to the right or left, depending on what direction your curb return alignments are going, and that should be based on, you know, jurisdictional requirements and kind of what way they need to see profiles and how your views are laid out. So, and then you have a lane piece to the left in our case. So when you're targeting this, you can see that this is just, you know, going out for, you know, 10 feet, whatever that may be. And you can also see that the limits of the corridor section, the baseline, are extending over the roadway. So we don't want that. So we want to pull our limit back, our region limit, so that the curb return stops at the actual PI of the curb. And then what you want to do is you want to edit your targets of that curb return, and your width target is you're going to select an alignment, and you're going to add so this is Melinda. Melinda is the intersecting street, the T street. We're going to add that one. You're also going to add 2nd Street, so the center line of 2nd Street. And your target is going to be your profiles of those. So when you're targeting a profile, you first have to tell it what profile or what alignment you're going to try and find the profile from. We're going to target the FG, and then we're going to target the 2nd Street FG. Hit OK, and what it's going to do is it's going to basically, again, it's going to build out until it hits the first one that it comes to. So once it gets to this point, it's going to switch center lines and go over to this one, and it's going to transition that lane across and target the profile of both of these. Once it gets to that merge point, it'll switch profiles. This is one where you would want to increase the frequency of your corridor profile or sampling, because this will help kind of play out that transition. I'll warn you, you can get this a little bit too tight of a frequency, and it'll make your contours really jagged. So just kind of play with that and just make sure you're getting enough detail in your intersection to actually have it display correctly. So I'll turn the surface back on real quick. Oops. So you can see now it's kind of doing a blend of these two. You know, you can see a nice crown in the contours here, and then it's blending into the crown of the roadway coming down 2nd Street, or excuse me, Melinda. And then you would do the same thing on this side once you plugged in whatever that section is. This one obviously didn't have a curb, so you'd pick a different curb return section, and then those would all kind of blend together. I'll explain ramps real quick. So I mentioned we have that vertical height curb piece, or variable height curb piece. So along your curb return, you can split, again, go to split region, click your curb return, and then you'd split it at the top of the wing. That would create 2 sections. Then you'd split it again. You'd select that region, and you'd select the bottom of the wing. Then you'd split this next one again and click the bottom of the wing on the other side. And then this one you'd have to split it so that this continues further, and you change your roadway corridor region so that it doesn't have a right side for this first 5 feet or whatever. But let's just say the top of the wing is at the end. So again, you can go to not corridor property. Well, you could, but I think it's easier to go to region properties and then select curb return, variable height curb drop or rise. So drop is the start point. So again, it's always going to build up station. So it's going to start at the lower station and go to the higher station. So it's important that you get these in the right order. So the variable height curb, when you're adding it to the assembly, looks just like a regular curb piece. But when you add that in, if you go to the curb piece for the drop and you look at the properties of it, I think it's A is the start height and B is the end height, if I recall correctly. Oh, no. It's the start height and end height parameters that you want to change. And this says feet. Don't be alarmed. That is inches. So what that now does is it'll calculate the start of this region. It'll know that the start height is 6 inches, and by the end of the region, it's going to calculate a variable height across this curb and take this to 0. Then you would change this region here to be a curb return flush curb. And then you change this next one to be curb return variable height rise. And in theory, you can see the contours slowly dropping down the wing. It would then be flush across the curb, and then you'd see them rise to get to full height exposure. So because of that piece, that is why I always build the curb in the corridor and then tie your feature lines into the back of it. Does that make sense to everyone? Kind of, hopefully. Anyone have any questions on intersections or the variable height curb piece?
Hey, Mike. So, I don't know if we want to get into too much detail, but so how would you deal with that situation right there, the right wing of the
one here?
Yeah, to make sure it builds to not full height at that. Would you extend the station, or would you? Yeah,
so what I would do is your curb return profile, and this is another reason why you generally always build your curb return profiles to extend beyond the PI and PT, or PC and PT, so that you can get an extension on that if you need to. And again, because you're targeting center line, it's going to fix your contours are going to be the same regardless of if it's building from the curb out or from the center line out. So what you would end up doing is, if you needed the left side of your roadway to be different than your right side, you could just extend this no right section, where it's just the left lane and then the catch line or whatever's on this left side. You could extend that, or you could even split your baseline region of your main roadway. You could have another point here. You basically deal with that in your main roadway and then extend your curb return profile further around.
Got it.
And again, like I said, there's ways you can build these ramps in your corridor. I I sometimes build my driveways in that because they're a little bit simpler. But if you wanted to do that, you'd have to do a bunch of links or sidewalk pieces that are targeting each of these, basically your ramp wing, your top of ramp, and then your end of ramp wing. You target a feature line for width and slope, or width and elevation, and it'll build that in, and then it'll build to the back of walk. But you got to keep in mind that it's always going to build your sample lines perpendicular to your baseline, which isn't always how you need to calculate cross slope of your sidewalk, which is why I don't often do that for curb returns. So I'm not going to actually open a corridor model of a half street, but they're effectively built the same way. You know, most jurisdictions want you to profile center line, and they want their alignment and stationing based on center line. So you would build it the same way. Let me see if I can just build a quick. We'll just build a quick assembly here. Half street. Sure. So if you're building it off center line and your saw cut is, you know, say it's 10 feet away, or say it's variable, you can use these generic links as the first one. Again, you can do width link offset and elevation, or link slope to an elevation. I think it's link offset to an elevation, or link offset on surface. That's the one you want. And no, that's not the one you want. It's link width. I think it's width and slope. And I think what you can then do is, you know, add a lane to the backside of this. Say you didn't have a pavement section or a curb. So say that was your half street, and this was the start of your saw cut. So the slope doesn't really matter. The width technically doesn't really matter either. What you can do is you can select this link, and under properties, there's this parameter that says omit link. If you say yes, it won't build that link in your surface model or in the model. But what it can do is let's do this quick. Add a region here to there. I didn't name this anything, did I? Sure. What did I name this? Half street. So you can see what that does is it builds your corridor, but so it's building it off the center line, but it's starting it out here because we've got this link in here that's going 10 feet at a specific slope. If you were trying to build this basically to a start point, you could either cut a profile along your saw cut line, which occasionally we have to show anyways, at which point you could then, you know, target that on your width and slope link. You can target that alignment, your saw cut alignment, and then target a saw cut EG profile. And what that would do is it would then basically model out to this point in the background, calculate these elevations along the existing profile, and then build your lane based on that. That makes sense? Kind of. I know I can't show that very well here because I don't have a I don't think. Yeah, that just says the target. I think that's the best one. Let's see. Did Halverson leave? Halverson, do you know if there's a if I'm missing one here? I thought you could target a width to a surface. It could be offset on surface. But anyway, that's the probably good timing because I think my computer just froze. Oh, it's because I just deleted the entire corridor. I wouldn't recommend doing that, by the way. Make sure you don't have the corridor selected when you hit delete. So anyway, any questions on any of that? I know that was a lot to cover in an hour, roughly, in CAD. Anyone still awake?
I'm here, Mike.
Thanks, Mike.
Yeah, Mike, we're here.
Yeah,
It's just a lot of information to absorb.
yeah, it is. Mike, where are you gonna save this video to?
I have no idea. Sarah, where do these get saved to? Do you know? Sarah did fall asleep. I'll work with Sarah on where it gets saved. We'll try and get it saved to the training folder. Oh, does everyone know where that is? Portland shared, Portland training, and then 2020 events, and then there's a folder for corridors.
Yep. That's right.
Yeah, Mike, I think that'll be
these
really key
PowerPoints.
for this one.
Yeah, there's a lot of information. This one that like I probably could like having this and going around side by side, step by step, would probably help me make a good corridor.
Yeah, I'll work with Sarah to try and get the recording saved. I was going to try link offset on surface. Okay, well, I guess if no one else has any further questions here, we can, I suppose, call it.
And Mike, I think you mentioned this earlier, but Sean hasn't gotten back to you, right? Or
he
did
is
give a
not.
timeline?
I am still going to be working with Sean to try and figure out a better method for half streets. And I guess I'll try and explain the difficulty that we have. So if you have a roadway that needs a curb and gutter, so again, we generally build out from center line, because that's how it's easier to display our, the stationing and the profile that's needed for the jurisdiction. Yeah, this is the one you want. You want link offset on surface. So it'll basically start at an offset, and you tell it what surface to start at, and then it'll build the lane from there. So that's the best one for starting at a saw cut, but still basing it off center line. Sorry to sidetrack. So the issue that we have is when you have a curb and gutter, and generally on a half street, you are designing the flow line profile because we don't have a finish grade profile that's going to be a consistent road slope across the entire section. So you may have an existing road that varies from a cross slope of 1% to 3%, and to get longitudinal slope on your roadway, you may need to vary the cross slope of our road section as well. So what the issue is in order to model that with a corridor, but get the gutter pan modeled as well at a 8% or 5% or whatever the jurisdiction detail shows, because the corridor always builds from center line out, you actually have to model your flow line profile, or your curb profile actually has to be set at the edge of gutter pan rather than your flow line, because it's going to go from your center line or your saw cut line, and it's going to set a variable slope on your lane piece by targeting that profile that's at your gutter pan, the edge of your gutter pan. Then you're going to model a piece for your gutter itself that's at the 8%, and that's going to be consistent across the entire length of the road. But in your plans, you need to display your flow line profile and label your flow line profile. And your flow line profile needs to be labeled based on center line stationing. So you're stuck by building it from the center line out. You have to make basically what's a copy of you have to design your flow line profile and then build a copy of that as your gutter line profile or your gutter pan profile, so that you can target it in your corridor. And it just becomes a giant mess because you're only using the edge of gutter pan profile for building the model. You're not going to display it. And then you're only building your flow line profile, which should be just a direct copy of your edge of gutter profile, just dropped by an inch or whatever the delta of your gutter pan elevation is. You have to build that one so that you can display it on your sheets. So it becomes a big mess on how that's, and adds a lot of locations for error, because if you update your model by updating the profile of the edge of gutter pan, you have to remember to go back and update your flow line profile to display properly on your sheet. So you're using one for the building of the model, you're using one to display the sheet, and it just becomes a pain. So I'm working with Sean over at Autodesk to see if there's a better way to do that, either by linking the two profiles together, or having the corridor have a bunch of if-then statements in it that look one way or the other, to see if if you have a gutter pan, do this. If you don't, do this. Yeah, I don't know. Half streets are, like I said, that's why we didn't do this brown bag on a half street design, because it's much more complicated. Same general concepts, but definitely much more complicated. And I guess while I've got everyone, I'll take one more minute here. If you are doing one way that you can limit the number of sections you have and the thought that's required on whether you're a cut or fill section or a cut or fill catch. In a lot of cases, if you're a if you're like in our case here where we had a V ditch on one side of the roadway, if we're a fill section, we needed to do something different than if we're a cut section. So there's what they call conditional sub-assemblies for cut and fill slopes. And what it lets you do is, instead of just doing a daylight here at this point that would either look down at 3-to-1 or up at 3-to-1, what it does is it calculates if you're a fill or a cut, meaning if you're above or below existing grade or whatever your target surface is. And if you're a fill, it'll add a bench before it daylights, or it'll add whatever you want it to add before it daylights. If you're a cut, it'll just catch up to existing. So you can use the corridor to build multiple things depending on if you're in a cut or a fill scenario. And I suppose you could use those for, for walls and things as well. If you're a fill and you're right up against the property line, you needed to do a wall. You could set those up in a number of different ways. So I just wanted to touch on what a conditional subassembly is, because those are helpful on a lot of different cut and fill scenarios on the perimeter. Okay. Well, I think with that, if no one has any further questions, we can wrap this one up, let you guys get back with your day. Sorry for running a little long here. And I'll work with Sarah to get the video saved.
Thank you, Mike.
Yep. Thanks everyone for your time.
Awesome. Thanks, Mike.
Appreciate it.
Thanks, Mike.
See you guys.